Hey!
Jai Guru, good evening. It's Vaishish from 10A. So today I'm going to take a topic sign conventions. So I'm going to compare the sign conventions with Cartesian scale. So this side I'm going to take it as x-axis and this side I'm going to take it as y-axis. So this is positive and x-axis, this is negative, positive and negative. So the first rule in the sign convention is the object is always placed on the left of the origin or the pole which we compare in the mirror. So the object is always placed on the left of the mirror. This implies that the light rays which are coming from the object also is coming from the left side of the mirror. This we can take as F. And
F means what? That also you have to say.
Focus. So this is focus. So here is the image and this is C. So I'm passing the object at C, and the image also come exactly at C. So this is my ray diagram for real and inverted concave mirror. So in case of real and inverted, the object is always placed on the negative side. The image will also be always negative. F, C will always be negative. So the first thing is the object is always placed left to the mirror. So light rays are also coming to the left of the mirror, and this object, it is always measured from the pole. So this is the pole, or in case of Cartesian scale, you can take this origin. This distance is always measured from the pole. For example, the focal length that is between the pole and the focus point, this is measured from the pole. The image distance which is measured between this point and this point is also from the pole, and is the image and also object distance from this. All things are measured from the pole. So everything, any distance. Second rule is all the distances are measured from the pole. Third thing, the distances which are right of the origin, that is or the pole, are taken as positive, and the distances which are taken from the left of the pole or the origin are taken as negative. If the object is right here, then it is taken as a negative, and if the object is right here, it is taken as positive. So in case of a real and an inverted, object and the image of a concave mirror are always considered as negative. This is what the rules of the sign convention states for a real and an inverted mirror. And the last two are...
Wait. You have to say little slowly.
Yes. And the last two things are the distance which is measured perpendicularly above the principal axis, parallel with the principal axis, above the principal axis, are said to be positive, and the distance is measured perpendicular to and below the principal axis are taken as negative. Now this is the rules for the real and inverted of a concave mirror. Let's see about the virtual and erect images of a concave mirror. So, as usual, drawing a Cartesian scale, origin, pole, x-axis, y-axis, y dash, x dash. And in case of a virtual and an erect mirror. So, we know that concave mirror can produce two types of images, real and inverted and virtual and erect. Let's see in case of virtual and erect.
Slow.
Yes, ma'am. F, C, and my object is right here.
Middle you have to ask the doubts. Anybody can ask the doubts. What is C? What is P? Like that.
Here my object is. So here my object is standing here. This is my object. And then my image. So here you can observe that the rays are going like this, and we will not get image on a screen, or in case of virtual and erect image. In the previous example, real and inverted, we got an image like this, and we got it to see in a screen. But in a case of virtual and erect, we cannot see it in the screen. Except in case of virtual and erect, the image will be formed behind the mirror. So like this. Here is the place where this image will be formed. So
why are you saying it is a virtual? Why are you saying it is a virtual?
Virtual and basic difference between virtual and erect and real and inverted is, in real and inverted, the image can be got on the screen and we can see it on the screen. But in a virtual and erect, the image would be formed behind the mirror. So here, in this case, the rays are not meeting at the point, and the point where they meet, they have to meet on a point. So they meet behind the mirror. So the image would be formed behind the mirror in case of virtual erect. So this is in case of concave mirror. So in this case of concave mirror, here the object is taken as negative. Object, which is u, object distance is taken as negative. V. So here.
What is u and what is v? You have to explain first.
U is object distance. U object distance. V image distance. Object distance, and V, this image distance, is taken as positive because this side is positive and this side is negative in case of Cartesian scheme. So this is taken as positive, and then the CF and the distance between the pole and the center of curvature, that's R, radius of the curvature, that is negative. R is negative and F is negative. The focal length, so that is negative. So everything in case of concave mirror, virtual erect, everything is negative except the image distance. So this is only in the case of virtual erect, the image is positive. Else if it's real and inverted, the image will also be negative like everything. Now let's see of the convex mirror.
I have a doubt now.
You can ask.
You ask
Wait.
first. So, if the object is beyond C, won't the image be captured between C and F? And it's a real and inverted image. How can you take it as virtual and erect?
No. The image is, object is not right here. Object is placed.
First rub it. Please rub it, and what she asked, that doubt you have to put that diagram and then you can have to explain.
Yes, ma'am. So actually, in case of beyond C, C and F, the image would be between C and F.
Oh, yeah.
But what I have drawn is at F. So the object is itself at F only. So that's why the image which should be formed is behind the mirror. So in case of beyond.
What is the difference between virtual and real?
Huh?
Virtual and real difference.
Virtual means object will be behind the mirror. We cannot see that image cannot be caught on screen. But in the case of real and inverted, it can be caught on screen.